Okay, hi. My name is Viktor, and I had a demo this Friday for profiq about our progress in tech research, specifically around building autonomous agents using large language models. Unfortunately, the recording of the video doesn't have any sound, so I'm re-recording the video now, just so we can share it with the outside world. This is going to be really a demo. I will try to showcase the framework in a couple examples and then our specific use case using these agents to help with automated QA or end-to-end QA of web applications. But I definitely recommend checking out the article by Miloš about this framework and this research. Because it goes into much more depth and it's more technical around the topic. It's no longer going to be a live demo, but I hope it's still going to work on one take and I'm not going to have to make too many edits. So first of all, about agents, what are they? So there's many definitions, and this is a kind of a hot topic of research right now in large language models. But I think at the core is kind of allowing language models to take action, to give them some agency by providing tools. And because language models are just text in, text out, the way you do this is you structure your prompt in a way that you get some specific structure back from the agent or from the LLM. And then, based on this structure, you can choose and call specific functions in your application logic or, some external API and so on. Just to give you an idea of this, so this is the kind of the OG agent prompt, which is from the React framework. And so you basically explain the rules of the game to the agent or kind of specify the behavior that you want. And then you explain the format, and the traditional format is you get some question from the user. So this is the prompt that's gonna come from the outside world, from your users. And then you encourage the agent to think about the next step, about what action it wants to take. So it's always good to give the LLM a couple tokens to think about the problem. And then it specifies the action. So this will be a specific name of a function in your code or some API it wants to take. And then it gives you some input for the action. And then it's going to continue generating. It's going to continue hallucinating the observation. It's going to return its own kind of observation from calling the tool. But as soon as it starts generating the observation, you basically cut it off and call your internal logic, call your application, and then return from your application back to the LLM through the observation. And then this can go on. It can, repeat a couple of times. And the agent basically calls all the functions it needs to fulfill the original question. And at the end, it will just give you a final answer. This is the standard prompt, which is for LLMs that just have this, text in, text out API. But because OpenAI models are, I guess the state of the art right now, and they are very good in their performance, and they have a specific structure which is not just text, but they specifically train the models to kind of follow the chat API. So it's, a system message instead of this prefix. And in the system message, you can explain the behavior. And then you have a history of interactions, which can be either messages from the user or the tool calls or whatever, just the history of the conversation. And then, it will respond either with a tool call or with the final answer to the user. I will be using this format in this demo because this is what we use in the framework, since we are focusing on OpenAI models. But then you can imagine it's very transferable to, models that don't have this chat API, and you can just structure it in a different way, maybe something similar to this. So talking about our approach, so we wanted to experiment or research these autonomous agents. And so we did evaluate existing frameworks that are on the market. And we like them. And this is definitely, so we wrote our own framework, but the goal is definitely not to replace any of the existing frameworks. Everything that I'm going to show you, you can probably rewrite in LangChain, and you will have a lot of the community support and the tooling that's around LangChain. The reason we decided to write our own framework is because the logic for writing an agent is not as complex, and we wanted to basically understand it and control it as much as possible. So this is the reason we really wanted to just dive deeper, but the goal is definitely not for this to be a production framework. It's experimental framework where we basically try what works and what doesn't. We, as I said, use the OpenAI models, so the structure is kind of chat-based, and it's what you will see in most of the other agents. We have some things that are a little special or maybe new. So we do have the system message. So this is to explain the behavior and kind of give the instructions to the model about how you want it to behave. And then we have the interaction history, which is the message from the user, and then the individual tool calls and the responses from your application. And then of course the tools, the kind of description of the tools that the agent can use. The thing that we are adding is basically for each interaction, for each request to the language model, we generate and append a context message, which gives the LLM kind of the current image of the world, or current state of the environment. So you can imagine, if you have a text editor, for example, the current contents of the text file would be in the context message, but it can be whatever. And the way we add functionality to the agent is through plugins. So we wanted to make something that's modular, that could be reused in different contexts. So we have the core agent, and you can add plugins to the agent, and plugins are similar to applications, I guess, but instead of user interfaces, you are building kind of these LLM text-based interfaces. So you could have a text editor plugin, which will, through the context message, give you the current state of the editor, and then you have tools to update line 3 or search and replace or whatever have you. And then you can use these plugins in different contexts, right? So the agent can have multiple applications or multiple plugins active at the same time. And they give it kind of the view into the world and then the hands to manipulate it. So this is about plugins. I'm gonna show you specific examples of plugins, and then the other thing we kind of emphasize in the design is we wanted to build a tool, and it's a very simple UI right now that allows human supervision. So we kind of checked and played with some of the agents, and they are not always very reliable right now with the current models, especially with the smaller models like GPT 3.5. And so we want to train them to be better and to fully understand this and kind of be there and steer the agent in the right direction. I think it's important to have a good tool to supervise the agent, to help it, make decisions, maybe even provide your own kind of actions that the agent can then learn from. So this is what I'm going to show you. I'm going to show you a couple examples of plugins that I have written just for this demo, and kind of how to work with them in the context of the framework and of the supervision UI. And then I'm going to finally show you the example of actually using this to browse the web. So let's get to the first example. And this is a very simple file system plugin, right? So I mentioned the text editor, so this is basically it, right? So we have a simple plugin. It extends the base plugin class. And it just has some directory and some file. And in the context message, it gives the LLM the directory structure. So the directory tree under, the working directory that we have the agent in. And then if it has some file open, it also gives it the name of the current file and the contents of the current file. Otherwise, if it's empty, it says it's empty. And then we have just two very simple tools. One is to open a file, so it can see a file in the directory structure and give the path to open it. Or if it doesn't exist, it can create a new file this way. And then it has a way of updating the current file. So it has some file open and it can update the contents of it. So this is just a simple example of a plugin, and then here is how the UI looks like. So let me explain the structure a little bit. So I already have an agent loaded for the first demo, and this is the settings for the agent. So I can choose the model which is used. This is gonna come into play a little bit later. And then this is the system message I was talking about. So this is where we explain the rules of the game or the desired behavior to the agent. And the scenario for the first demo is basically I am a startup founder. I'm taking my notes in Markdown on my file system, and the assistant or this agent has access to the notes, and it can basically read them and update them. And let me just copy the prompt here. So this specific example is I get a link. You can imagine like, the share button on Twitter or whatever. And I send the link to the agent. So this is the title of some article, fake article, the URL. And I add some thoughts I had when reading the article, for example, and I want this noted in my Markdown notes, right? So I can send it to the agent. It's going to run for a little bit. You can see this is the context message I was talking about. So we generated the directory structure for the agent, and you can see that I have some daily notes. I have some projects that I'm working on, and I have some resources. And this is where I would like to take notes about the article. And then this is the potential generation from the agent. So this is the potential action, potential interaction, we call it. And it wants to open the daily node. And this is where the supervision first comes in. And we can show it on the example. So this is a good, interaction, I guess. I could note the things about the article in my daily node. So this is a valid action, I think, but I specifically wanted to, have the article in the resources folder, and then in the daily node just link back to it. So I can change the system message on the fly. I can say, always create the node in the article folder, in the resources folder first, then link it in the daily node for today. And as soon as I submit it, the agent is trying to generate a new completion. So the prompt stayed the same. The context message, it was generated again, but nothing changed in the directory structure. But now I can see that the agent gave a different interaction or different action in what it wants to do, and it wants to first open this resources node for releasing our image generator v3. So this is the title of the article. And you can see we don't have this node yet in the resources, so this is gonna create a new node. And I can commit the completion, and that means that the tool is gonna execute, it's gonna do the action, it's gonna save into the history. So here you can say, I have my original prompt in the history, then I have the call from the agent, and then I have the response from my application. So the file was opened, and then I have a new context message generated with, again, the daily nodes, the project, and the resources, but under the resources, the new image generator article or node was created. And then the agent has the file open currently, and the file is empty because it was just created. And so it wants to update the current file with some notes about the article, so we can let it do that. And again, as soon as I commit it, it's gonna end up in the history. And we can see that the file has these new contents. And now, just as I stated in the system message, in the instructions, the agent is gonna open the daily node. So we can let it open it, and then it's hopefully going to read it, right? So in the context message, as soon as it's open, it's going to change to the contents of the daily node, and then it's going to try to update it. It actually wants to update, multiple other things, but here's another way basically that we can control the agent. So I could just rerun the script and try to get a different completion, but again we have multiple function calls or multiple tool calls, and it's not exactly what I want. So I can say here that I specifically want the update current file tool to be called, and the agent hopefully is going to do that. We're going to let it run for a little bit. And you can see it wants to update my node with the there's probably going to be the link to the thing. So we can let it do that. let's check how the updated nodes look like. And you can see that it linked to the newly created node under the nodes header. So, I had to come in there and change the behavior of the agent. I had to, update the system message a little bit. And I had to force a function call at one instance. But this is, kind of cheap supervision, kind of cheap interruptions or cheap input from the user. And this way, if you kind of put yourself into the shoes of the agent and you teach it to use the tools correctly as you want, you are generating, a good data set of the behavior that you want from the agent. So you can basically think of this as kind of a playground where you can experiment very rapidly, change, parameters on the fly, and specify the tools you want to call, and it's gonna give you a training data set for an agent that you can then use in production. Now, let's go to an example that's gonna be a little more involved, a little more complex, I guess. And for that, let's look at another plugin. So, as I said in the original example, I showed that it's good if you give the agent this space for thought, right? Space to think about what's the action that it wants to do next. And this is true for every language model. This really greatly improves the performance. So we want to do this too in the for our agent, basically. So the way we can introduce this is we can write a simple planning plugin, and the planning plugin is just gonna append to the context the steps the agent has planned. And if it doesn't have any steps yet, or it hasn't planned any steps yet, we can just say no steps have been planned, use the update plan tool. And then we give it a simple update plan tool, which, we explain that it's important to think about the next steps and next actions it wants to make. And we let it basically prepare the steps before it starts executing them. So let me get back to the demo and let me just load it. Okay, and now we have the second agent loaded. Again, we have some settings for it. The system message is very similar. But the scenario now is that I had a meeting with an investor and I had some notes from the meeting and I want to update, the project and specific note for the meeting and then my daily note with these notes or with the summary of the meeting. And so we're going to use the same plugin for the file system, so it can still access the nodes, it can still update them, open them, and so on. But now it can also plan using the planning plugin. So let's call this a meeting. Let me copy the prompt for it. And send it to the agent. So the prompt is, I just finished the Zoom call with the potential investor. Here's what you need to note, and then some notes from the meeting. So I can send it to the agent, and you can see we have the same directory structure as before, but now we also have this part from the planning plugin where it says no steps have been planned yet. And so I was talking about the supervision and about generating this data set of correct behavior, of correct way to use these plugins and these tools. So the other way we can control this is you can see that the GPT 3.5, it wants to just go straight to opening the daily note, and it doesn't actually use the update plan plugin. So I can just try to use the, stronger, more expensive model, and it's gonna probably use the update plan tool correctly. Let's see if that's true. And then it can also do better at planning, right? So it's a stronger model. It costs more, but if we use this more expensive model for the planning, then it's much easier for the cheaper and smaller model to execute the plan because it already has the steps prepared, and so it knows what to do. It's just following instructions. So basically, I could go in there and say, call the update plan tool, and I could type in the plan manually. That's also a way of supervising the model. But I can also say, just use the more expensive model for the planning. It's going to create the plan, and then the cheaper model is going to execute the plan. So let's commit this. Let's see what the plan is that it figured out. So it will open the file, update it with the details, and it's going to open the daily note and update or link the series funding pitch into it. So it wants to open two files at once. This is something, again, I'm here, I'm looking at how the agent works, what are the common mistakes it makes, and I can basically take this learning and go back and update the prompts for the agent or for the tools, just the description, so it's easier to use it correctly for the agent. This was just an example for the demo, so I'm not going to do that, but I can just force a single open file tool call. So it's going to open the Series A funding as it says in the plan. We can open it. Wait a little bit for the completion. And so, we can see there's already some content for the file for the Series A funding, but we can update it. So the GPT 3.5 knows to update it correctly. It will add in the notes that we had. It wants to, open the daily note, so we can do this. And just let it run for a while. And you can see, the daily note is open. It wants to update it, to add the notes from the meeting, and so on. So this is, another example of how we can basically add another plugin just to do the planning. And then let's actually jump into the example where we are using it ourselves for the web automation. And you can see that this planning plugin, even though I have written it, for this example of taking notes, I can use the same plugin and then combine it with a different plugin, the Playwright plugin that gives access to the browser, and it's still going to be useful. So these plugins or these applications for the LLMs are, modular, and you can combine the agent with the specific plugins that you want. So let me just open up the third demo or the third example. And so now I have the third demo loaded. So this is the basically core of what we are doing, right? So we are not using this agent framework for taking notes, even though this might be a interesting project as well. But we are trying to use these agents for web automation. And so this has many stages. We are experimenting with multi-agent scenarios for proposing test cases. So one agent is executing the test cases or clicking through the page, and the other one is proposing Gherkin scenarios or Gherkin test cases for the test suite or for the application. The other stage is you need to prepare data in some way for the test case, prepare your environment. So this is an interesting application of the agents as well. But the main thing you need if you want to do web automation using LLMs or LLM-based agents is you need an agent that can control a browser, that can navigate and control web applications no matter what the application is. And so we are doing this by writing a Playwright plugin. So we have an agent that can that will get a browser instance with Playwright, and it can basically see the contents of the web page. It can click on things, fill in inputs, and so on. And to evaluate the agent or to train it and test it, we are using a Mind2Web dataset. So this is a huge dataset of websites and tasks to do on those websites, and it's a great way to evaluate agents that control the web. I will show you a specific example. So the thing I pick is the calls website. So this is an e-commerce website. I think it's with art or something. And the prompt is, please go to calls and browse for wall art with price range of $25 to $50. You can see it already opened up the browser window for me. And this is the structure of the context message. So we give the HTML of the website to the agent. I will talk about this in a second. Then we summarize the HTML or give a description of how the page could look like given the HTML. And so we use another LLM to do this. And we've seen this improving the accuracy very much of the agents. Instead of relying on just the HTML, if it has the description, it's much easier for it to plan the steps or choose the right action. And then we have the same plugin as we had for the note taking. So we can take plugin and use it in the notes example, but the same plugin is going to be very useful for the web automation as well. So this is kind of the reason for structuring the code as plugins, because then you can reuse them. And it wants to go to the calls website, so let's just commit this completion and let it do that. And I can show you how the actual HTML looks. It's gonna just take a second to load. Okay, and now that it's loaded, you can see that the HTML looks like this. We actually do a lot of trimming on the HTML, and we clean up a lot of, things that are not important. So a lot of the attributes or elements that are not useful for the LLM. We trim out elements that are not visible on the page. So, if it wants to go under the fold, basically, it has to scroll a little bit. And, we formatted nicely. So it's a little verbose, the HTML, but, again, this is a development tool. This is not for the end user. The UI for the end user could be just, it tells you to go to calls and browse for wall art, and then all the intermediate steps that the agent needs to take. This is just for the agent. This is not for the human, right? Unless you are supervising the agent and you are trying to teach it how to control the web and how to do this. Here you can see the description of the page. So, it has various sections. It has the global header, menu bar, marquee ad, and all of that. And then it hasn't planned any steps yet. We'll get to it in a bit. And then we have a screenshot of the website. So we don't send this screenshot to the model, to the agent. This is possible already. So GPT-4 has the vision model, and there are some open source vision models as well that can do this. And there's actually a project that specifically focuses on web automation or web agent using vision models. It's called Web Voyager, and I encourage you to check it out. And they see some great results with this. So they annotate the screenshot to show the LLM what are the interactive elements, and then this is how the LLM can control the web. We try to stay in the text environment as long as we can, because we have already seen that this is quite possible. It's surprisingly good, even with just the HTML, or if you help it with some summary or description of the HTML, it can do pretty good. And it's going to be much easier to train or fine-tune a smaller model on this training data if it's just text, right? Working with the vision models, it's much more expensive in the inference stage, so even when you are just using the model, but then fine-tuning it or training it further, it's just quite expensive. So we try to work with it in the text as much as possible. So now we can see it wants to input the wall art into the search field. So let's commit this as well. And just wait a little bit. You can see it input, and now it wants to do this again, which is strange. So we can just try to refresh the completion, but it's doing the same thing. So again, we skip the planning, which is never a good idea. So we can, switch to the more expensive model for the planning, and it's gonna propose a plan for the, for the scenario or for the case, and then this is gonna make it much easier for the cheaper model to follow. So let's do that. GPT-4 gave us the plan, and we can just wait for the next step to finish. Okay, and now we can see the plan is here in the context message. So the agent knows what to do. It clicks the search button. Let's commit this and continue. Now we can see that the page was still loading when we took the snapshot on, or when we were generating the context message, so we can just rerun it again so that we have a fresh and loaded website basically. And now it's everything is loaded. We still have the same steps to take. We have some description of the page. And so now the price filter is somewhere in the sidebar, so the model wants to scroll down. So we can commit this and let it scroll down. Okay, and now we can see that the browser is scrolled to the bottom, so we can see the price selection in the sidebar. We have to expand this section, so it wants to click the span which contains price. Hopefully this is the right selector. Let's commit the completion. Let's let it run for a bit. And now we can see that this worked. So the section is finally expanded. We have the list of all the price filters that we can use. And so it wants to click on the one that has $25 to $50. Hopefully this is the right selector. Let's try to click it. Wait for a little bit, and you can see that the page reloaded and the price filter is applied. So we are now browsing wall art, which is in the price range of $25 to $50. And we can scroll down on the page to see more of the products. But this is the idea, right? So it's finished. There was some supervision, there was some input from me and some help from GPT-4, but you can see that with this supervision the agent was able to complete the example or complete the task from the Mind2Web dataset, and then we are saving all these requests, all these completions or interactions, and the whole history of this task. And this helps us build a data set where the promise is we can train or fine-tune a smaller model on this data set and have it perform without need for the human supervision, or without the need for input from these larger, more expensive models, and hopefully even without the visual input of the screenshot. Just from a text-based agent, we can have it control the web on various websites with various different styles of buttons and forms and inputs, various different stylings, and so on. So I think agents in general, this topic of autonomous agents with LLMs is quite interesting, and we're going to be hearing a lot more about it. And hopefully we can contribute to the discussion, and we will definitely share more from our research as we go forward. But for now, I think this is it, and I thank you for your attention. And since this is no longer live, please leave the questions in the comments or wherever on our LinkedIn, and we'll be happy to answer. And all the code that I used for this example is in our public repo, so this will be shared with the video as well. And you can play with it yourself. Thank you.